Today we're going to take a look at some exponentials as well as logs. So we're reviewing some properties of exponents, and then we will connect these properties to logs throughout this unit. First rule, if you multiply powers together, you add the exponents to simplify. Of course, all of these properties require that you have the same base. As a reminder, if you have x squared times x cubed, x squared means x times x, and x cubed means x times x times x, so you can see you have 5 x's being multiplied together, or the 2 plus 3. The second rule is our division rule. For example, if we had x to the 5th divided by x squared, and we wrote this out the long way, we have 5 x's being multiplied in the numerator, and 2 x's being multiplied in the denominator. So 2 of those x's will cancel, leaving us with x cubed, or 5 minus 2. The third rule links back to that second rule. So there's a couple of different ways to look at this one. If we had x squared divided by x to the 5th, rule 2 says we can subtract those exponents. 2 minus 5 is negative 3. But if we write this out the long way, x squared is x times x, and x to the 5th is x times itself 5 times, and we cancel 2 of them. Notice how those 3 x's that we have are left in the denominator. Of course, x divided by x is 1, so that's where the 1 in the numerator comes from. I'm running out of room on the right-hand side, so I'll do the fourth rule showing how that works on the left-hand side. And this one again links back to rule number 2. If you have x squared divided by x squared, rule number 2 says subtract those exponents and you get x to the 0. Without writing this out the long way, we know that anything divided by itself is 1. So that's why x to the 0 power, or anything to the 0 power, is 1. Rule number 5 is just an example of the distributive property. Rule number 6, a lot of students tend to get that confused with rule number 1 when you have a power times a power versus a power raised to a power. So if we have x cubed squared, squaring means multiply by itself, so we'll take x cubed times itself. Then we can use rule 1 and add those exponents together. And rule number 7 is another example of distributive property. Our goal today will be applying properties of exponents as well as logs. Starting off with simplifying some exponent expressions, there are several different ways to start each of these questions. It depends on what makes the most sense to you. Students tend to have a harder time with negative exponents, so I recommend making your negative exponents positive by flipping them first and then trying to simplify with all positive exponents. So in the numerator, the 6x will stay there. The y to the negative 5 will move to the denominator, but the y to the negative 5 in the denominator will move to the numerator. The 9x squared stays in the denominator, and again, that negative 5 from the numerator is moving to the denominator. Now we can simplify. 6 over 9 is a fraction that can be simplified, dividing each of those by 3. X over x squared. When we simplify expressions, we don't want any negative exponents. So we can subtract those powers, but your answer goes where the largest power is. In our case, the largest power is in the denominator. So when we do 2 minus 1, the power on the x in the numerator, we get a power of 1, but our answer will go in the denominator. And of course, y to the 5th divided by itself will cancel out. Example B, we have no negative exponents, so that will be helpful. In the numerator, I will start by distributing this power to just what is inside the parentheses. I will not square my 5. X squared squared, we multiply those powers together, and then we have y squared. You can drop the parentheses at this point as well. In the denominator, that 5 is being squared, so I'll get 25, and then 2 times 2 gives me x to the 4th again. 5 over 25 is a fraction that I can simplify. Dividing each of them by 5 cancels in the numerator. We get 5 in the denominator. X to the 4th divided by x to the 4th will cancel, and we have y squared left in the numerator. Now we're going to look at some properties of exponents with numeric bases. Make sure you're following order of operations. That negative on the outside will stay there. That means multiplication by -1. So we will cube our -3 first and then multiply by the -1. -3 times -3 is 9, times -3 is -27, and the opposite of -27 is +27. Next example, that 2 to the -3 will move to the numerator and the exponent will become positive. 2 cubed is 8, and 16 times 8 is 128. Part E, that 2 to the 4th will move to the denominator and that power will become positive. This next step we can use our power rules. The numerator is really 2 to the 1st, so we can subtract those exponents and our answer goes where the larger exponent was to begin with. Our larger exponent is in the denominator. 4 minus 1 is 3. Of course, 2 divided by 2 is 1. That's where the 1 in the numerator comes from. And 2 cubed is 8. We're going to go back to practicing evaluating with logs. Since that's new, I'm assuming you're going to need quite a bit of practice to get the hang of how logs work. Remember, the answer of the log is the power. 2 to what power is the square root of 2? Well, the square root is the 1/2 power. Part B, 3 to what power is 1 over 27? For some of you, it might be helpful to rewrite this as exponential form. Rewrite that 27 as a power of 3. 27 is 3 cubed. But of course, we need to pull that out of the denominator. When you are flipping a power from a numerator to a denominator or vice versa, you make the sign on the power opposite. So this becomes a -3. So log base 3 of 1/27 is -3. Part C, we have the common log of 0, which is log base 10. So it says 10 to what power equals 0? If you remember from graphing our exponential functions, we had an asymptote at y equals 0. We could never get an answer of 0 from an exponential function. Therefore, you can't take the log of 0. This one is no solution. And finally, we have 1/6 to what power is 36. This one may be helpful to rewrite in exponential form as well. Couple of options here. We could turn our 36 into 1 over 36 to the -1st power, or we could flip our 1/6 to 6 and then make that exponent negative. That one I think might be the easier route to go as it gets rid of the fraction. So again, I'm changing my 1/6 to 6 to the -1st power. And then using my power rule, I'll multiply that -1 by the x. Of course, 36 is 6 squared, so the opposite of x is 2, which means x equals -2. So log base 1/6 of 36 is -2, because 1/6 to the -2 power will flip that fraction and then square it. That'll give us 36. And you have a few U-try questions.